Okay, welcome back to the EI conference 24, the day one, the first session of a short talks and panel discussions. This is our tradition to have the leading researcher from the world giving a short presentations about their perspective about embodied intelligence, and then followed by intensive discussions. So the first session we're going to do is I'm happy to invite Cecilia Laschi from the National University of Singapore as the discussion leader. And then we're going to have 4 other speakers presenting their work on embodied intelligence. And I just have a very small changes in the program as Carlos Gesherson needs to give a talk earlier than is planned. So maybe Carlos can give talk right after Cecilia, and then everyone else will follow after that. So hopefully that's going to be okay with everyone. Okay, so then I will hand over to Cecilia. So yeah, please do share your screen, Cecilia, and then and then you start presentation followed by discussion. Okay, so I hand over to Cecilia, and you're experts of this conference, so you know how it works, and hopefully you can coordinate a very stimulating discussion. Cecilia, thank you for joining, and thank you for helping us.
Thank you for me. I'm so happy to be here. This conference is becoming a very nice tradition for our community. I'm happy to open these short sessions, so I have to keep an eye on the clock to be short enough to have at the end enough time for discussion. So I'm not going to elaborate here about embodied intelligence, because I know this is a very well known topics, but a little bit about its relation with soft robotics. I'm a roboticist. I consider myself as a roboticist. I work in soft robotics, and I think that the reason why we came up with soft robots is exactly because of embodied intelligence. So we know very well that according to the embodied intelligence paradigm, adaptive behavior emerges from the interaction with the environment. And if we learn how to use it in robotics, we can simplify our task, our control task, our sensory motor control tasks. And in order to do that in robotics, we have to learn how to make use of such interactions, mechanical interactions from the environment. So we need compliance in the body. This was a big, let's say, a small revolution in robotics, because usually compliance is something to fight in traditional industrial robots. So this is, for me, the real rationale for soft robotics, which is also something that we learn from nature, because most living beings are actually soft, even if they may have a skeleton to negotiate gravity. So how to put that in robotics? Generally, we use to depict our robotic system like this. It's very nice that Fumi also started with this kind of drawings at the beginning. I swear that we didn't discuss before. So in general, we have a part that is the motor part, the actor here interacting with the environment, a sense part. In robotics, we are very good in this motor part. We are very good at developing closed loop controllers that are very accurate to control the position of the robot. Our robots also have sensors that receive information from the environment. We can process this information. Generally, we have some level of intelligence here. My drawing is very, very general, using some word model. I must say that robotics research has focused this part very much. In the past and even today, we try to study neuroscience, to take brain models and use them to give intelligence to our robots, to give some cognitive functions to our robots. So what happens now is that we have to consider the embodied intelligence, which is not in this traditional robotic system. So where is it? It's very simple to add embodied intelligence here. If we just add a small arrow from the environment into the mechanics of the robot. If we do that, we can sort of close a very small, very fast, very short loop, control loop here. And this is actually the main hypothesis that we do. So, I'm sorry, we can probably focus on this if we want to add embodied intelligence in our robots. And in soft robotics, we are very much focusing on this part, forgetting a little bit about the rest. So how to use this for designing our robots, our soft robots at this point with embodied intelligence? Can we fully capture embodied intelligence if we can model both arrows and couple them together? This is something that, as you see from the reference, was discussed already in this conference, in the last edition of the previous one, I don't remember. And this is something that we also discuss in this paper. We propose that in order to model embodied intelligence and use it to design and build our robots, we have not only to model the internal interaction. This is something we are very used to in robotics. This is the effect of actuators onto the body itself in a soft robot, in the deformations of the soft robot. But we also have to model the external interaction and couple them together. And we proposed one equation that contains all this. It's a very general one. There is a term of the equation that describes the soft body, and then two terms that describe such internal and external interaction. This is the very general form of it, but depending on the modeling technique used, those terms will assume different forms, and we have all the equations for that. So this is also my research focus now, one of my ongoing research. So we are studying this, my favorite animal, the octopus, and this very interesting movement. It's a reaching movement in water, underwater. So it's very different from the way robots move underwater. And you see that the animal does a very smart, intelligent bending that reduces the water, it reduces the area where the water drag can act. And the distal part of the arm is also passive, so that part actually receives the water drag. So this bending is done not only by the muscles, but also by the interaction with water. So we have everything we look at. It's a perfect example of embodied intelligence. Despite the many muscles involved, only 3 parameters are set by the brain. So a huge simplifying principle for control. So we are now modeling all the aspects involved. So you see here a model of the muscle activation. This is the preparation, and this is in a moment the real reaching movement. But we also model the fluid dynamics involved, and of course we also are designing and building some prototypes. This is unpublished. The prototype is actually an old version. We have new versions already. But the idea is to demonstrate that this movement is efficient energetically with some numbers coming from the modeling, coming from the fluid dynamics, to demonstrate that in robotics we need different strategies for underwater manipulation. So going back to my point, as I said, we are very much focusing on this, forgetting all the rest. And this is a bit what the soft robotics community has been doing. Of course, this was the most important, relevant part. We were very happy to understand that this part is important. And we want the roboticists to learn that we have to put it, but maybe it's time to consider the rest also. So it's not exclusive. So the two things should stay together. We should put it back and find a way to have a complete system like this one. So the question that I am posing to today's discussion is it time to try to mend the gap between these two forms of intelligence? So the soft robotics community focusing very much on embodied forms of intelligence, and the let's say wider robotics community, which I belong to also, more focused on, let's say, more cognitive forms of intelligence. Are we ready to put these things together? And I think that the session that we are going to listen to right now has all the ingredients to put these things together. There is an important missing thing here, which is the human component. Where is the human component? And our session actually includes a talk by Silvestro Micera, which will also cover this part. So this is my point for today. We have to go towards a really integrated system and considering all different forms of intelligence. And please enjoy the rest of the talks, because they are going to touch actually all these different levels and aspects of intelligence. Thank you.